Ever wondered how to build a fully dynamic, vector-based character rig that walks, runs, and talks down a street in real time? No pre-rendered keyframes, no heavy video editing software, just pure React, HTML, and SVGs running in the browser. In this video, we'll build a programmatic character animation system from scratch. First, let's look at procedural kinematics. By simulating a continuous walking gait cycle, we can move our character down the street. The legs adapt dynamically, keeping the torso moving smoothly while maintaining contact with the ground. To transition into a high-velocity run, we increase the step frequency and stride length. We tilt the torso forward to convey momentum. And we raise the hip bobbing amplitude to create a flight phase where both feet leave the ground. We also build standing and talking gestures. By animating organic arm swaying and lip-syncing mouth deforms dynamically, our character can converse with the viewer. We update the coordinates of the speech bubble in real time. To make the limbs bend, we use inverse kinematics. Instead of iterative physics solvers, we use analytical two-joint IK. Using the law of cosines, we calculate the exact knee angle beta and hip angle alpha in constant time, preventing lag. A proper walk requires gait control by splitting leg movement into stance and swing phases. During the stance phase, the foot moves linearly backwards. During the swing phase, it lifts and arcs forward using a smooth sine curve. To avoid stiff, robotic strides, we simulate foot rolling. As the leg reaches forward, the foot rotates up for a heel strike and rolls flat on the ground. Finally, it lifts off with a toe push transition. Let's trace the full walk gait timeline. The stance phase maintains support flat on the ground. As the foot exits, the swing phase lifts it into the air to take the next step, alternating between left and right legs. In contrast, the run gait timeline incorporates a double flight phase. Because the character moves faster than the stance speed, there are periods where both legs are in the air. This creates a natural, energetic bouncing movement. Next, we need to animate the spine. A stiff torso makes characters look unnatural. By adding a multi-joint skeletal spine, we can bend the upper body organically as the character walks, runs, or reacts. We model the spine using forward kinematics. Each joint coordinates its rotation relative to its parent. Local coordinates accumulate down the chain, rotating the pelvis, torso, chest, neck, and head in sequence. To deform the outline mesh smoothly, we apply linear blend skinning. Vertices of the body outline are weighted between neighboring joints. When the spine bends, the mesh deforms smoothly, preventing creasing at the joints. Finally, we adapted the character to walk on slopes and stairs. Real environments contain hills, slopes, and stairs. Our terrain-adaptive character balances its hips dynamically to match the height of both feet. We calculate foot placement by querying the terrain height under each foot. We cast downward rays to detect the slope under each heel. The target foot heights are fed back into our inverse kinematics solvers to flex the legs appropriately. To maintain balance, the hip height is adjusted to the average of the foot heights. The torso tilts slightly to align with the slope. This allows the character to climb steep stairs and slopes naturally. And there you have it. A complete procedural 2D character rigged entirely using React, HTML, and SVGs. Check out the open source code on GitHub. Thanks for watching, and see you next time.